In this video, I will demonstrate two simple PLC programs to show you the operation of a PLC trainer, and more importantly, to show you the relationship between the input status and the status of virtual contacts on the screen of the program editor. Right now, I have a Allen Bradley Micrologix 1000 unit on a homemade trainer hooked up to 6 input switches so I can simulate discrete input conditions to the PLC. It's connected through a serial cable, DF1 connection, to my laptop computer, and here I'm using RS Logix Micro to program the PLC. What I'm going to do first is I'm going to create a new project. So this is going to be for a Micrologix 1000. And here I see I'm offline. I see a blank screen for my ladder editor. I'm ready to edit. What I want to do is insert a new rung. So I right click on that line, go down to insert rung. That's a brand new rung of ladder logic. So I don't want to modify the one with the end statement. I want to produce a brand new rung. What I do here is I want to pull down a contact, a virtual contact, and insert in that rung. I'm going to name that contact. I'm going to tell it which I/O point on the PLC I'm going to use. And just randomly here, I'm going to choose the last input, discrete input point of my PLC, which is input number 5. That corresponds to the final switch, the 6th switch here, inputs 0 through 5. So I'm going to choose number 5 as my input. I could choose any one of the 6, it really doesn't matter for this demonstration. So I'm going to go I for input, colon, element 0/5. The slash is the bit delimiter. So that right there tells me that the number 5th bit is the one I'm going to be using. And here I can also add a symbolic name. So I'm going to call this input switch. One of the features of this editing program is that if you insert a space character, it automatically converts that into an underscore character, because typically spaces are forbidden for variable names in a computer. So there I have a contact. I need this contact to go over to a coil. So I'm going to grab a coil from my tool palette up here and drag it over and put it there on the screen. Once again, it prompts me with the question mark. It wants to know what the output channel of that coil is going to be. I have 4 output channels in this particular PLC. I can choose any one of them randomly. I'm going to choose output channel number 2. So the way I assign this, I type in O for output, and then I say colon, element 0/2, the slash mark being the bit delimiter. Once again, it prompts me for description and a symbolic name if I wish. I'm just going to call this output. I strongly recommend you get in the habit of naming all of your coils and contacts in your program to something that actually makes sense. So here we have an input switch, input bit number 5. We have an output coil, output bit number 2. So when I energize the switch over here for bit number 5, that energizes. When this program is running, it should likewise energize bit number 2 on the output. Right now, nothing's happening because I have not yet downloaded the program to the PLC, nor have I switched the PLC into the run mode. So we'll do that right now. So first I'm going to go up here and click that to verify the project. It verifies the project, checks it, says down here, verify has completed, no errors found. My next step will be to download it. So I go up into this corner of the software here and I select the download option. And right there it says, okay, we want to give it a name. Sure, I'll give it a name called test. And I will click save. And it's prompting me, are you sure you want to proceed with the download? Yes, I'd like to do that. Now it's writing all the files to the PLC through the DF1 cable. Coming back over here, it says, do you want to go online? Absolutely. And I see right now in the corner, I'm not in the run mode, I'm in the program mode, the remote program mode. So I'm going to switch that now to the run mode. Are you sure you want to change the processor mode? Well, yes I am. I click on that, and now I'm running. And you'll notice suddenly the bars over here turn red. I have the color highlighting on my editor set so that red is the virtual power. Right now, the input is not energized. See, the light is off. Therefore, this normally open contact right here, this virtual contact, is shown in its normal state, not passing virtual power. Likewise, the virtual coil over here is shown in its de-energized state. There's no red over there by the coil. And correspondingly, the real output right here is not energized. Now watch what happens when I turn on switch number 6. I turn that on, energizing input bit number 5, and immediately output bit number 2 turns on according to how I programmed the PLC. Keeping the switch in the on position, I go back to the display, and here we see this virtual contact, bit number 5, is energized. It's now colored red. It's passing virtual power over to virtual coil bit number 2, and that in turn is energizing the output. So as I turn the switch on and off, you'll see the highlighting come and go on the editor display. You can also hear the clicking of the PLC's relay output. And if I focus in on the display of the PLC, you can see if I turn this on, input lights up, output lights up, turn it off, they both go off. Very simple program. I'm going to go back here, I'm going to edit this program. To do this, in this particular version of MicroStarter Lite, I need to go offline because it does not allow online programming. Then here what I'm going to do is right click and I'm going to change the instruction. What I'm going to do is instead of using an examine if close, or what we call a normally open virtual contact, I'll make this an examine if open, or what we sometimes call a normally closed contact. I'm now going to verify the program. Everything checks out okay. And so now what I'm looking at is a program where I have a normally closed virtual contact. It will pass imaginary power onto the virtual coil when the real life input is de-energized. So what I need to do is take this program, download to the PLC, and go to the run mode. So there I'm downloading. Yes, I want to download. Change back to run mode. Absolutely, I want to go online. And here we show power flow in red. I'm sending virtual power through that normally closed contact over to my virtual coil, which is shown in red, energized. And if we look at the real PLC, we see that the output, bit number 2, is energized when the input bit is de-energized. Turning the switch on, the input energizes and that de-energizes the output. So this program is exactly the opposite of what I had in before. Before, these two lights corresponded with each other directly. When the input was energized, the output was energized. But here they're opposite of each other. And the reason for that is that normally closed virtual contact that I put into the ladder logic program. So looking at the program as I flip the switch back and forth, here the input switch is off. Now I'm going to turn it on. That energizes the input, and it makes this virtual contact open up so it's no longer passing virtual power. And that de-energizes the virtual coil, turning the real output off. So input bit on, output bit off. Turn the input bit off, the output goes on. When the input bit is off, its corresponding virtual contact is passing imaginary power onto the virtual coil, energizing the output. So I have an opposite or inverse correspondence between input bit 5 and output bit 2. And that shows a basic concept of coil and contact programming and ladder logic for a small PLC.